Okay. Last two sections that we're going to do briefly, and you should read these over yourselves as well. Section 3 and Section 4, and Section 3 boilers. And you've studied all the components of these before anyway. All the reboiler is a shell and tube heat exchanger. It just has a different use. And normally what happens is that we have steam that goes through the tubes themselves. And then we have a gas, some sort of process gas that goes through the shell side of the heat exchanger itself to, in effect, reboil it so it can go back to the process itself. And normally these are fitted in oil and petrochemical plants or any chemical process plant where there's distillation towers. Anybody know what a distillation tower is?
Great, big, tall.
Yeah, tall, big, tall, for any oil and petrochemical places, and that's basically, if you were, say you put heavy oil at the bottom, okay, and then at the very top, when you take it out of the distillation tower, you get light oils. It could be bar salt or, butanes, ethanes, ketones, all that kind of stuff. So that's just the example of oil and petrochemical. So basically what happens is you put the stuff here in the bottom and you boil it off, and then at certain temperatures and pressures, you take off, okay, the different types of oil and petrochemical. It's distillation power. They use it. That's just the example of the oil. It's basically crude oil. It holds true for a number of things. Waxes is another one that comes to mind. They basically, at certain temperatures and pressures, you just take off whatever you need. However, what happens with any process is that there's always a mixture, or there's always, unfortunately, there'd be areas in here where some of the material gets condensed, and we want to reboil it again to send it back to the distillation tower. So it's heat recovery, or it's a process recovery system. So reboilers are shell and tube heat exchangers found in gas processing and petrochemical plants. Okay. Again, shell, generally horizontal, with the tube bottom placed inside it. The steam flows through the tubes across, the process liquids flow around the external surface like this. Okay. Excess liquids that are not vaporized overflow from the weir plate and pass to the storage or to another process. There's three types of reboilers. Okay. There's kettle and what's called a thermal siphon. The third one is a vertical. Okay, so these ones are obviously horizontal. Vertical, it's pretty simple. We'll see that in a second. Just that this puppy has turned out its head. That's all. Okay. Notice one thing. It's the dead giveaway. If you ever see these out in the field, okay, most shell and tube heat exchangers obviously are going to look like this. Okay, and then you've got basically your connections here. Okay, this is all one side. Okay, dead giveaway with a reboiler. Okay, is that it's got a bulbous shell on it, like that. Okay, so what basically would collect at the top?
Yes.
The gas. Exactly. So this is the bulbous part. OUS actually, bulbous and bulbous valve, bulbous. Anyway, so that's a dead giveaway of what a reboiler looks like, really. YouTube, straight tube, same configuration. Now, this is a good drawing good sketch to know, because that'll be part of the question that I will ask right there. There's a distillation tower, really. Okay, just a general sketch of it. Okay, or fractioning tower, whatever you want to call it. Okay, and then this fits in there, and you'll notice. Okay, does that one actually show it? And it sort of does. should be a little, that level there, and the gas and the liquid level, sort of corresponds with that. That's generally the way they are. Okay. Sometimes the level will be a little bit different, but you can walk through any photo picture chemical plant, you'll be able to see the three boilers. And they'll have gauge glasses on them. And the gauge glasses are always floating like this because the liquid level and the gas level is fluctuating. But that's basically it. We got recovery vapor. We got basically they're called bottoms, basically, or it's a crud at the bottom of the distillation tower, which goes back into here. We use the steam, which is usually a byproduct of the process, to reboiler it, and then it goes back and we basically get more the heat recovery system, but you get more process out of it. So that's a horizontal thermal cycle reboiler. Okay. Figure 14. Notice this one. What's the difference between that one there, and this one here?
This one is fully flooded.
Right. So this one is completely wet. Flooded. Absolutely. Yeah. So that's a horizontal thermal cycle. Okay. The key difference is, okay, it's a thermal siphon. The reboiler or the heat exchanger is what? Fully flooded. That's a question that they ask. Okay. Whereas the other type is actually partially flooded itself. Again, this is all the same cell. You might get that in the question or two. Okay, explain the difference. Now, reboiler, steam side operation. Okay. Bring your heat exchanger. Okay, so this might actually broke your memory banks here on actually how to control the steam side of it. Alright. So on this one, what's happening? What's different with this one? Move through over here. What's a little different? It's a subtle difference. Sort of. But what are we using for the process here to reboil? We're using steam, right? Okay. So what can happen to the steam itself as the process is going on? Not only we have basically our solution in, we have our vapor coming out, we're reboiling. But what happens? This is the key difference. What can happen with our heat transfer media? Can we get phase change? Right.
let the process cool down more time in there,
Exactly.
get more heat transfer and steam will be better than that.
Exactly. Now that is the biggest key with these, is that they're a little harder to control because normally if we just have a water to water heat exchanger or something, or a standard shell heat exchanger, we don't get phase change on the heating or on basically on our media side, right? In these we do, because we're gonna condense the steam, we're gonna get condensate. So it creates a higher level of control problems or control issues. That's the one thing that you've got to keep straight in your head. Is that on the bundle side, we can have two phases, and that makes control a little bit dicier. Because essentially, we can our steam can boil, our steam is going to condense as it gives up its heat energy. This is going to work perfectly all day long, but most of the time, the control issues are on the steam side. Okay, so just keep that straight in your head. Is that you can have phase change on both the media side and the process side. Okay. So the steam to the inlet of the reboiler has a block valve which runs in the open position. The level transmitter on the steam/condensate side is connected to a level controller. The level controller sends a signal to the level control valve. The condensate flow through the level control valve is returned to the deaerator via condensate return header. Okay? Varying the level controller set point can vary the level of condensate in the tube side of the heat exchanger. This will expose more or less the heating surface to the steam. In this way, the amount of solution passing through the shell side can be varied. The level control can be a local or field controller, or maybe reside in the control room. Okay, we're worried about that too much. So basically, we are using the steam side, okay, to control the amount of output that we have from the heat exchanger. That's why it's different. Normally you would control the other way around, but in this case it doesn't. So, and it provides sometimes the control side is a little bit more, it's a little bit more intricate, a little bit more hairy. That's the main difference that you want to understand. Now, I'm not going to ask you the intricacies of the controls. This is the controls course, but you just have to understand how that works out. Okay. Now, I want you to take 2 seconds. This, I would say, is one of the most popular applications. Okay, just take 5 minutes and just read that page here. Okay. Again, you don't have to know the intricacies of how the levels are controlled or whatever. We just want to know that this is also used as a feed water heater. Okay. That is actually one of the, this would be a large, large feed water heater system. So essentially what we're doing here with this is that we're using, it's a heat recovery system basically. And we're heating our what? Yeah, we're heating our feed water load. Okay. So this is our hot well, and then there's a condenser, actually. Okay. So how does this basically work? Okay. We have a vertical reboiler or a vertical shallow tube heat exchanger. Okay. So notice this though. If you remember right, if you remember back to your steam knowledge, your steam plants, if we got a turbine plant, okay, normally we're using what type of steam? Superheated, right? So in order, once we're done with the turbine, no matter what it is, basically we still have superheated steam in our process somewhere. And in order for us to be able to utilize it somewhere, we have to actually bring it back down with saturated steam curve so we can condense it again, right? So there's our surface condenser, there's our hot well, and we have flash steam and stuff there. So that gives us the ability from our system, basically, we're bringing it back down to the saturated steam point. And that allows us, okay, to leak steam from the turbine here, okay? We're using that to assist us in preheating our feed water, but we're also bringing it back down to the saturated steam curve. So we can actually condense it so we can reheat it again, basically. And that's quite common in any turbine plant that are first or second class plant. You won't see a lot of this actually in a plant that's in a smaller saturated steam, basically. But this is one of the first things. This actually came out of the ships originally too. It's having steam some way of actually de-superheating. And this is a great way to do it because we got to preheat feed water all the time. So what I would ask you is this would just be it'd be a subsection of a question. Okay, not an essential question standalone by itself. But when you're ready, if you haven't written your curves already, you might see a question or two on this, and it could be these questions could be in any of the sections. Everyone can knowledge in this section anywhere, so that's why I bring it up. Okay. So basically, that is the part on reboilers. Just to basically review, and giveaway is the bulbous shell. Okay. Because we're trying to get vapor, we're actually reboiling our vapor again, so we can send it back to our distillation tower, so we can get more process out of it. Okay. And then in the two types of applications, down. Okay. Operation of horizontal thermal siphon. Okay. That's a kettle type reboiler. Okay, and the difference between these two is that the thermal siphon is fully flooded. Okay? And the kettle type reboiler, if you look at the level there, okay, it's supposed to be sort of closer so that the gas side is, it might be a little bit lower, but you see how the top part of it is completely gas. Alright? So that's the German type reboiler, okay, and the thermal siphon, that one's still fully flooded all the time. That's the subtle difference, okay? And this is basically the same. And these at the bottom of this, these are called bottoms or bottoming, residual bottoms. There's all sorts of different names, but it's basically the stuff that's stuck at the bottom of the distillation tower that you want to get more good stuff out of. That's all. More process. Okay. Here, and that was flooded. This is a quick question. Why? Which one of these do you think is actually better? Or is there advantage of one over the other? Actually, that's one of the ones that's a debate that's gone on from day one. Which one is easier, do you think, to control?
Easier to control?
Yeah.
It's thermal siphon.
Right. Yes, the one that's flooded completely because you don't have what?
Phase change.
You don't have phase change. And again, and we have phase changes on both sides, it would have made it tougher to control, okay? So that's exactly right. Okay. And then the reboiler. Okay. The reboiler is inside operation. Okay. And again, this goes into that's a really like CPU controls course. That's one of my favorite controls questions how that actually works. And it becomes dicey when you have phase changes on both sides. And normally, when you're talking heat exchangers, you do not ever want phase changes on both sides. For obvious reasons, right? Much tougher to control. Excuse me, and that's one of the reasons that a lot of them are things like this. A lot of them are completely flooded. And then where's the heat water heater? And again, the reason for this is that in a turbine plant we've got to actually condense. We've got to condense our superheated steam. So we've got to bring it down to a saturated steam curve. But anyway, so we might as well dissipate some of that heat energy by using it to heat our heat water. Alright. That is the section on reboiler. Okay, and that'll be, like I said, one standalone question on that. Alright, let's just take a break for 2 minutes here. I gotta get out of this room a little bit warm. Let's stand outside for a minute. And then we'll be late for any extinguishers.
Shall we do the pause?
Please pause.